For our transition table, the key ingredient is actually, number one, the design of the table, which is really meant to be smart and simple. But number two is really just focusing on one state at a time. So when we're drawing up our overall table here, we're going to have our states on one side. So we're going to have state 0, state 1, and state 2. And by the way, this is how we would program this. Obviously, we can't program a drawing. We would turn it into a transition state table in order to really do our programming, what functions would be called, and all that good stuff. So then we're going to have our two inputs of our alphabet, which is just A and B for this standpoint. That's all it is. So nothing really crazy when it comes to that. Now here's where I focus on just by the states. At state 0, if I was given an A, here's state 0, or really, oh, you know what? I really should. I know it said S in the lab, but I'm going to use Q just because I'm used to that. And again, if you used S or Q, it doesn't matter. But let's see here. Q0, Q1, Q2. All right. If Q0 was given an A, it gets me back to Q0. If I had a B, it would send me to Q1. Okay? Just two highlights that we have right here. All right, next. That's all of my outputs from there. So I really should actually take care of the edges. Taking care of those two. Now at Q1. Q1, if given an A or a B, they go to Q2 just because of this line right here. So this is going to go to Q2, and that's going to go to Q2. And again, check off that line. All right, now for Q2, if I'm given an A, it goes to Q1. Check off that line. If I'm given a B, it goes to Q0. So notice I'm checking off the lines. We had one combination of one, which was A or B. Be careful, not A and B, but A or B. But other than that, that's about it. But this is really what we would actually start programming if we were to continue in our Lex to build that transition table and go from there.